This lecture is focused on food safety. As one of the three media we will focus on, air, water, and food, food has an important role in protecting your health, and there are lots of ways that we use food and can control how it's treated to reduce illness from it. For this chapter and the module, the objectives are that you identify measures for preventing foodborne illness, discuss 10 microbiological agents that are implicated in foodborne illness, understand the significance of this type of illness worldwide, describe categories of contaminants in the food supply, and give examples of major regulations protecting the safety of food from cancer-causing agents. Foodborne disease and infection are illnesses acquired by consumption of contaminated food, often referred to as food poisoning, but that's not quite correct. An outbreak is the occurrence of similar illnesses among two or more people, which is linked to consumption of a common meal or food item, with one exception for cases of botulism. Botulism is so rare and so severe that any one case of this illness is identified as an outbreak. Globally, foodborne illness causes major disease and occasionally death in the United States and other countries of the world, and it has increased in many industrialized nations. There are many factors that contribute to this increase, including changes in agricultural and food processing practices, the globalization of food distribution, where food produced in many different parts of the world will be shipped and consumed in other countries, and also social and behavioral changes among the human population for how we treat food, how we process food, what types of food we're consuming. In the United States, foodborne illness affects almost a quarter of the population, resulting in up to close to 10,000 deaths and, of course, a huge economic cost for days lost at work, for time spent seeking medical care, and sometimes being hospitalized. We do surveillance of foodborne illness through the Centers for Disease Control and Prevention. They maintain an active surveillance network called FoodNet, where they contact laboratories to identify new cases of foodborne illness. This is where laboratories are processing samples from humans, usually feces, and they can identify different bacterial agents. Sometimes they may identify other agents that aren't bacterial, like viruses or parasites, but it's mostly focused on bacteria. If we think about where this surveillance system detects cases of foodborne illness, it's really where someone has gotten ill enough to see a doctor, and that doctor recommends that that person give a stool sample. That sample then goes to a laboratory. Many times people are exposed in the general population, they become ill, but they never seek care. There are 4 categories for food hazards that we'll discuss in this presentation. Biological, where microorganisms or toxins from microorganisms contaminate food. Physical, so plastic, metal. Chemical, where pesticides or other chemical contaminants are found in food. And then nutritional hazards, where perhaps presence of nutrients or other constituents could lead to disease or even sometimes an allergic reaction. Bacterial agents of foodborne illness include commonly occurring ones like Salmonella, Clostridium botulinum, Staphylococcus aureus, and Clostridium perfringens. These are all what are called bacteria, which means they are single cell or unicellular organisms that have characteristic shape. Some are shaped like a rod, some are spherical in nature, or some look like a spiral. Salmonella is an infection that results in the disease salmonellosis. These bacteria are rod-shaped, they can move around, They have characteristics of the surface of their cell that indicate that they're gram-negative, and they're non-spore forming. And non-spore forming bacteria are more vulnerable to heat and inactivation procedures. The common types in the U.S. are Salmonella enteritidis and Salmonella typhimurium. It's one of the most frequent types of foodborne illness. Approximately 2 to 4 million cases, including all of those that don't seek care, are estimated to occur each year, and it causes a small number of deaths, about 500. Sources are broad. There's wild and domestic animal reservoirs. Of course, chicken are a major example. Animals that are used for human consumption, poultry, swine, cattle, pets, not just traditional domestic pets, but one source we've found commonly that can transmit salmonella to humans is turtles or other reptiles. And some are chronic carriers of the disease. How is it transferred? Often it's through environmental surfaces at work or home, from raw meats on a cutting board, and then you might go and use that same knife or cutting board to cut up vegetables that aren't going to be cooked. Of course, animal feces is another way that it's transmitted. Growingly, domestic pets, even baby chickens, are being kept in houses, and that's a good source. And then those feces can get into other settings like water or soil, on the surface of food, or when you're washing food. Symptoms often rapid onset: nausea, vomiting, stomach cramps, diarrhea, fever, headache, but you can also get some chronic symptoms, including arthritic-like symptoms that occur after the infection has mostly gone away. Clostridium botulinum is a bacterium that causes botulism. It's a form of intoxication. The bacteria, when it grows in the food, produces a toxin, and that toxin is very, very potent. The food has to be anaerobic, where there's not a lot of oxygen, and this potent neurotoxin can cause death within a short period of time at very low concentrations. Botulism is quite rare in the United States, which is why if we identify any case of it, we have investigated as an outbreak. There is an antitoxin that can reverse the effects, but it has to be administered rapidly, and the only agency that has access to this is the Centers for Disease Control and Prevention. After consumption of food contaminated by the toxin produced by the bacteria, within 18 to 36 hours, people will have very specific signs: weakness, vertigo, and typically progressing paralysis, where there's difficulty in speaking and swallowing, ultimately in breathing, and there may be other things. So this happens quite rapidly. Clostridium perfringens, which is the same genus but a very different species of bacteria, is also a bacteria that grows in anaerobic or non-oxygen conditions, but it's commonly found in soil and areas contaminated with feces. It's found in the intestines of humans and animals. Exposure to Clostridium is problematic because it's much harder to inactivate these bacteria. Clostridium bacteria are what's called spore forming, which means that at high heat they are still maybe stable and not completely inactivated. Symptoms from exposure and infection with Clostridium perfringens can include cramps, diarrhea, and they last about 24 hours. Sometimes symptoms can last 1 to 2 weeks. E. coli, or Escherichia coli, is a pathogenic strain of E. coli. There are lots of different types of Escherichia coli in the environment. Not all of them cause illness in humans. Most of them reside in the intestinal tract of warm-blooded animals like humans and other mammals. There's a number of strains, though, that cause severe illness. And E. coli 0157H7 is one that we've seen arise in the last 2 decades that's very serious. It causes colitis, which means it produces hemorrhaging in the colon and produces bloody diarrhea, but the concern is that this can go on to be more severe. There are approximately 73,000 cases annually and 60 deaths, and major outbreaks have happened in restaurant chains. It's often associated with hamburger meat and improper cooking conditions. Staphylococcus aureus is a common bacterium found on humans and animals. It's present in our skin, it's present in our nose, and when it grows in a food source, it produces a toxin that's very resistant to heat. So if you heat up that substance, it won't inactivate the toxin. It'll still be present and can still make people sick. The intoxication is very rapid onset, and ham is a frequent vehicle or a common source of food that's contaminated with this. If you've ever thought about the very traditional outbreak scenario where people bring potato salad to a picnic and leave the potato salad out in the heat and then others consume it, the culprit for that would be something like Staphylococcus aureus, where they produce a toxin, you consume that toxin, and you get very ill quite rapidly for a relatively short amount of time. There are some foodborne illnesses caused by things that aren't bacteria, that are multicellular organisms like worms. Trichinosis is one example. Eating a meat that contains a nematode, which is a roundworm from the genus Trichinella. Trichinosis is commonly found in carnivorous or omnivorous animals like pigs, and if the meat's not cooked properly, you can be exposed to these and then get the intestinal infection with the worm yourself. This is how pigs can transmit this organism to humans. Ingestion of undercooked meat is the main route that humans are exposed. Pigs get it from being exposed because of other animals that have it, like rodents or other pigs. And once the human ingests the egg or the larva of the worm, it will grow in the intestines of the human, and then that worm and larva or eggs will be excreted into the environment. Tapeworm is another type of multicellular organism that humans can get. It's often caused by Taenia saginata or Taenia solium, and these are considered commonly beef and pork tapeworm. Humans consume undercooked meat and can, like in that other picture, be exposed to the larva, and then a worm will grow in the intestines. Sometimes the effects of these type of worm infestations in humans are limited, but sometimes if the infection is heavy, it can block the intestines. Other types of microorganisms that cause foodborne illness include viruses. Viral agent that's commonly identified as foodborne is hepatitis A, often associated with fruit sandwiches, cold cuts. The common mode for this transmission is that one of the employees working in the restaurant is infected with hepatitis A and in a food processing plant or a restaurant and can easily pass it on to the food. And there's about 23,000 cases reported. 7% are believed to be food or waterborne. There is a vaccination that's quite effective, and many people are vaccinated now, but it's not all. Norovirus is a commonly transmitted virus, very common in closed environments. This is probably the most common illness seen on cruise ships. Many times a passenger brings it on board right before they get on. They're not feeling well, they get on board, and it spreads very easily person to person. The ship itself may actually act as a reservoir because the virus can stay infectious on surfaces for a long time. It rapidly disseminates because the virus often causes volatile vomiting, and it's easily transmitted to other people. Vomiting, diarrhea, dehydration, abdominal cramps, and these symptoms last for 1 to 2 days, and you feel quite terrible during those 1 to 2 days. Other agents that we are starting to understand besides viruses or protozoan parasites, worms, or bacteria are called prions. These are pieces of proteins, and the one that we identified maybe 15 years ago was bovine spongiform encephalitis. It was called mad cow disease back then. And what happens is cattle consume food that's been made from other cows and ingest this protein and become infected with a neurological disease that's progressive and ultimately fatal. There was a large outbreak in the late 80s, and it shifted the type of food that we give cattle. We no longer give cattle food made from other cows. The human form of the disease is called Creutzfeldt-Jakob disease, and it's been linked to exposure through cattle. Similar neurological disease with progression that can't be stopped, and ultimately it's fatal. These are very rare and frequent, but it does occur in humans. So we've talked a lot about microbiological contamination of food. Now I'll give you some examples of chemically related foodborne hazards. We've described the term toxin before. In the context of microorganisms, that contamination still would be microbiologic, but there are other examples of toxins in food that we'll talk about. Heavy metals like lead or arsenic are also potential hazards from food. Pesticides that we intentionally spray on foods to improve the growth and the quality of the food, herbicides, fungicides, veterinary medicines used in meat like antibiotics, and then additives for other purposes. So toxins are naturally occurring, and these in food are often associated with seafood or mushrooms and may be associated with illness. Marine toxins that are common and would be important to avoid, of course, are ciguatoxin, paralytic shellfish poisoning, or even pufferfish toxin. These are naturally occurring. Sometimes it has to do with conditions in the oceans or where the fish are being cultivated that can cause these. Metals in high concentration can cause illness quite rapidly. Lead, arsenic, or others. If you consume that in food, it would make you quite ill rapidly, but that would have to be at high concentrations. Some examples of where metals have leached into foods include from metal containers. Sometimes containers prepared in other countries have allowed for processings that don't normally happen in the US, and then those surfaces are painted with lead-based paints or treated with other chemicals, and that can allow the metals to leach into food. Certain species of fish can have high levels of mercury, and that could impact development of human fetus. So many times when women are pregnant, there's a recommendation for women to avoid certain kinds of food. Pesticides in food Pesticides are applied to crops to reduce insects, to improve growth of the food, but these can impact and may remain on the food after the food is grown. And diet is one of the main exposure routes for persistent organic chemicals that are associated with pesticides, particularly organochlorine pesticides and polychlorinated biphenyls. Sometimes animal husbandry practices require the use of antibiotics to sustain the health of the herd. This is true for poultry, cattle, and some fish feeding operations. And so there are allowable antimicrobial agents given to the animals, principally in the form of antibiotics. The cause for concern is the development of resistance in the population because these are easily overcome by different types of bacteria. Residues from these agents may persist. There may be toxicity, but also we're concerned that microorganisms can become resistant to these drugs. There are often additives provided so that the food has other qualities than beyond what it has while it's just being grown. So intentional additives add quality. Indirect additives may be the result of packaging, contamination, storage, handling, and then occasionally we might see intentionally malicious additives for purposes of harming someone. Preservatives are commonly used to preserve food, increase the length of time that the food is healthy. It reduces the growth of microorganisms. It can stop food from tasting poorly, turning brown. It can reduce the loss of vitamins. These are commonly things like nitrates, sulfites, etc. The Food and Drug Administration, which is an agency in the federal government, is primarily charged with regulating and enforcing food safety. The Department of Agriculture regulates specifically the safety of meat and poultry products, and those two agencies, or department and agencies, operate separately. There have been a number of important acts to help us reduce contamination of the food supply, improve the quality, and reduce illness. The Food and Drugs Act, the Pesticide Act, the Food Quality Protection Act. Most of these have been focused on reducing the use of additives that can be harmful, especially in terms of causing cancer in humans or animals. And they're allowed additives that are generally recognized as safe. One of the major acts that targeted the reduction of pesticides was the Food Quality Protection Act, and it established a standard that a substance could not cause a lifetime incidence of more than one case of cancer per million people exposed. So a food product could not have a level of that chemical above that. If they were to make some assumptions about how many times that person ate the food, for how long they lived, etc. These are major players in food safety regulation in the United States. I mentioned the U.S. Department of Agriculture, and they have the Food Safety Inspection Service, the Food and Drug Administration, which focuses on every other product besides meat, and the Centers for Disease Control and Prevention, which do foodborne illness surveillance. And then, of course, you would have a state-level agency. In Georgia, it would be the Department of Public Health. And then you might have county-level agencies like DeKalb County. So, for example, DeKalb County is the agency in DeKalb County that goes and surveys restaurants to make sure that the people are doing safe food preparation practices. The major way that we prevent foodborne disease is through improving the temperature conditions, making sure that cooling and cold temperatures are below 4 degrees Celsius or 32 degrees Fahrenheit, making sure that high temperatures are also being maintained above a certain temperature. So safe holding temperatures are above 140 Fahrenheit for hot foods and below 40 Fahrenheit for cold foods. The range between that 100 degree Fahrenheit range is considered the danger zone, when it's going to allow mostly bacteria to proliferate in that food and not stop them from growing. Other ways we prevent foodborne illness and contamination is very thorough hand washing, prevention of cross-contamination, which is not allowing microorganisms from one food source to get to another, especially if that food source is not going to be cooked. So maintaining separate areas for raw meats, fresh vegetables, making sure the food is cooked at adequate temperatures, and storing the food at appropriate temperatures, either in the refrigerator or maintaining hot food hot. We do often use irradiation to inactivate microorganisms and other pathogens, including pathogens. This does not cause the food to become radioactive, and it's been a method to reduce foodborne illness. One of the things that is used as a processing tool for reducing foodborne illness is called hazard analysis critical control points. It's used in a way to monitor the processing of food, and it began in the 1950s. There are 7 principles. First, analyze the hazard in the process. So if it's preparation of poultry or preparation of cereal, identify where the risks are to introduce contaminants into that food. Through this hazard analysis, identify the critical points that need to be controlled, set limits, establish procedures to monitor how those critical points are being met, and when something is violated, establish a corrective action. Verify the procedures and record keeping. For food safety, restaurant inspectors oversee the safety of food served in local restaurants. Every restaurant you go into should have a food safety rating in the state of Georgia, and you can often look up those scores online. You can see where they violated different principles in food safety, preparation, storage, serving. Epidemiologists investigate outbreaks. Microbiologists identify microbes that might be present in food, and government employees are inspectors who are involved in the processing of food animals.